I'm Elizabeth Berry, Marketing Communications Manager here at Lincoln Electric. Welcome to our first of many live cast events. Today we're going to be talking about pipe process, and I'd like to introduce our two product managers, Sheldon Ray, Advanced Technology, and Sheena Suvak, Alloy Consumable. Welcome, guys.
Thanks, Beth.
Thank you. So what are we going to talk about today?
So, Beth, what we're standing in front of is a pipe coupon, and particularly a stainless steel pipe coupon. Now, those of you in the pipe and pressure vessel manufacturing world are familiar with how this is typically performed. This is usually done with a welder taking a TIG torch and walking the cup up the pipe while depositing the filler metal. Now, that is done so they can get the highest quality weld, right? They get very tight control using TIG. What we're going to talk about today is to get that same high quality weld while maximizing your productivity. One of the ways we do that are with innovative technology such as the Lincoln Electric PipeFab welding system. Now, the PipeFab is a true multi-process welding solution. This system comes as a true ready pack, comes with everything you see here with the exception of the optional water cooler. Now, this is designed specifically for pipe and vessel fabrication. So this large, beautiful HD display is designed to withstand those environments as well. Now, I know that Eric is going to be doing an STT MIG process. We'll get into what that is in a moment, but I'm going to set that up for him now. So if I go here and I press in the center encoder on MIG type, I'm going to move it from low fume pulse to STT. Next, I'm going to change the wire type. I'm going to make sure that's 300 series stainless, because that's what we're using today. The wire diameter is going to be 0.35, and the gas type is going to be a 98.2 mix, because that's what I have on the back of the dual bottle cart. But it's not just the machine and the feeder that make us be able to do these fantastic welds. It's also the consumables. So here to talk about that is Sheena Suvak, Product Manager of our Alloy Consumables.
Thank you, Sheldon. It's so true. I always align what kind of wire or consumable we're using with the engine oil that you put in your car or the set of tires that you put on your car. It optimizes the performance and longevity of your vehicle. Very much the case of quality of welds and also longevity of your liners and your contact tips. The biggest difference with this Red Max 308 LSI that we have on the system today is the surface treatment. So it optimizes short arc welding performance. That means a shorter arc and a broader base that's going to fill in that bevel that much nicer, which we'll see there in a minute. Beyond that, it also aids in feeding and wire placement. So that means less wear and tear on your liners, contact tips, less changeover, downtime, and more arc time.
Thank you, Sheena. Helping us conduct this demo today is also Eric Stewart. So Eric has over 30 years in the pipe and vessel world. Eric, thanks for joining us today.
How you doing, Sheldon?
Doing well. So Eric, when you think about moving from a TIG process to do these routes to a wire-fed process, what does that mean to you as somebody with a lot of experience in this industry?
Simplicity. Typically with TIG, it's thought of as a higher skill set process. It's more labor intense because it requires you to have a purge, which requires setting it up. So you'd have to have a purge dam. You also would have to tape the joint off to make sure that you had a well-shielded weld pool on the inside when utilizing TIG. The MIG process is a simpler process, and we're going to be using STT today.
Great. All right, well, I'll let you get to that route. I'll follow up with you when you're done.
Okay.
Eric, that sounded pretty good. And by the looks of it, that looks pretty good also.
Yeah, so this is a 6-inch Get 80, and as you can see, I did not use a purge. So in some cases with STT, we would not need to use a purge. That would be up to the end user or the client, depending on what the environment for the weld is going to be at.
So you're not only getting a productivity improvement by switching over, you're also getting a cost savings when not having to worry about using the argon or nitrogen that would be normally used in a purge, right?
That's correct.
Okay.
Correct.
And Eric, out of a curiosity, what can somebody expect to see as a productivity improvement from switching from TIG to a MIG root process?
When using STT over TIG, it's typically 2 to 3 times faster.
So quite a bit.
Quite a bit faster. And it's also low heat input. So part of the reason we have to purge when we're using TIG is because the travel speeds are relatively slow. Therefore, if we did not have a purge, we'd be at elevated temperature for a high period of time, causing that black soot that we'd see on the inside or discoloration of the weld.
And you have one that you did earlier here, right?
Yes, this is an STT root.
Okay.
This was done without a purge, and as you see, if you look inside, you're going to see that's typically what we'd expect to see. Dull gray, not black. That is what STT would look like without a purge.
Awesome. And if we look on the outside here, you can see that you got good tie-in on the toes.
And you'll also notice that it's thicker than what you would get with TIG. TIG we typically would have to go over with a hot pass before we could go over it with a fill pass using, we'll say, pulse, for example, as we are today.
Yeah. All right, awesome. So next we're going to do a smart pulse fill, correct?
Correct. So if you give me this,
let's
I'll
do that.
Get it set up.
All right. I'll go over some of the stuff on the PipeFab UI while you do that. So as I mentioned earlier, one of the first things that people notice about this system is that very large and engaging user interface. So let's go over some of the things that you see on the screen here. If I look in the upper left-hand corner, you have the wire feed speed. Right now it's set 2 inches a minute. Over on the right-hand corner, you're going to have either the voltage or your trim. Now, down beneath that is the mode that you're in. So here is MIG STT root pass. Underneath that are the parameters for that mode, 300 series stainless, 035, as well as the gas mixture. But underneath that is something very key. So we developed this technology some time ago, and it's a patented Lincoln Electric process for giving you the exact energy regardless if you're using a pulse mode or a modified short arc. So that true energy value stays on the screen at all times, and it'll always show the value from the last weld. So right here, we know that Eric welded at 34.1 kilojoules of energy and for 23 seconds. Now, if I go to the More menu here on the bottom, let's go and see what's in there. So this first layer of the More advanced settings has the ability for you to adjust your 2-step or 4-step interlock. What that means is you have an operator that can click the trigger once and let go to weld, then they can click the trigger again and let go to stop welding. Now it's 4-step, as opposed to traditional 2-step where the trigger must be held down the entire time in order to continue welding. And next to that is our Ultimark value. Now if I go into here, you'll see we have a visualization on the right-hand screen. Now that's also a Lincoln Electric patented thing called arc effects. So what that allows us to do is as I change the Ultimark setting, if I move it over to soft, you can see that that arc broadens up and it shows you how it's going to change your arc profile. Now this isn't a parameter that you'd be using to get your weld to lay in a good weld to begin with. This is just to fine tune it so you get the exact arc characteristics you enjoy. Now if I rotate it over to the other side, you'll see that it narrows up and you get a stiffer, more digging puddle. So Eric, how you doing over there?
Doing pretty good, Sheldon.
All right. So I'm going to change this back to the home screen. I know Eric's going to be using our mini Pantheon, so I move it over to the left-hand side. And I know he had his memory saved at 1, so I'm just go ahead and press 1. So Eric, how are we going to be performing these welds today for Smart Pulse?
Well, we're going to be utilizing the mini Pantheon. This particular unit we have here is a 6x6. A mini Pantheon is basically, the purpose of it is to take the torch out of the welder's hand to basically relieve some of the stress of standing over top of a weld, along with gaining productivity from doing this. You'll see here that we have, it's a pretty simple basic setup. We have a controller here. This basically will adjust what our travel speed needs to be based off the diameter of the pipe. We have our horizontal adjustment, which is back here, which will align us based off the top dead center on our pipe. And we also have the controller here mounted on the mini Pantheon, and this allows us to set up to 8 memories. And with those 8 memories, we can set it per the pass, okay? Now, in this case, I'm only going to use 2 different variables, right, for the fill passes. So I'm going to save in memory 1, and I'm also going to save it in 2. So I'll do my hot pass at a little bit colder than what I would do with my fill passes. If you look, we also have the ability to change parameters. I would be changing what is the weave width. I'd enter in the value, hit enter, and then it would be saved. I can also adjust what is the weave speed along with dwell. So I could dwell on the right side longer than the left side if I had a little bit of misalignment issues, or if I had, I was welding a flange to a piece of pipe and I had a false bevel that I had to catch.
So this allows the operator to maintain a very consistent oscillation throughout the entire pipe, right?
That's correct. That's correct.
Great. All right, well, while you do that, I'm going to actually show them what happens on the UI while you're welding, okay?
Okay, sounds great. Ready, Sheldon?
Ready when you are. Eric, that looks great.
Thank you.
So not only did we get a nice consistent weld, but we didn't have to have the operator, hunched over the pipe the entire time for that long weld, right?
That's correct. And so I basically, as an operator here, once my programs are set, I also have the ability to center it within the joint. This one here had a lot of, we'll call it misalignment there. And also you're able to adjust the height. Okay, so what this leads to is higher productivity gains, because as an operator or as a welder, I don't have to continually walk back and adjust parameters. I can do everything right here, and all I'm doing is really just adjusting the height in between passes, which leads to me welding more and walking less.
Awesome. And typically with stainless pipe, there's always a lot of variables that you have to account for, right? And so typically there's usually a lot of spatter involved. So using the smart pulls, the spatter is down, right? We have a much more reduced spatter. We didn't need a sense lead for either the STT or smart pulls to get that nice control.
That's correct. Our group spent a lot of time developing what is the PipeFab, and in developing what is Smart Pulse, we tried to take the welder into consideration, right? So whether we want a wide arc, or if we're welding a 1G rollout, or if we wanted to weld in position, we wanted a more focus arc. We've adjusted all of that for the operator. So basically, he just sets the wire feet speed, and we adjust the arc based off of that wire feet speed.
Great. We have some samples here, right? We can look
Yes,
at.
sir. So what you have there is a piece of 6-inch Sked 80. Okay, I have the 6-inch Sked 40 here. This represents a root pass and a cap pass. This represents what will be a 5-pass weld. So I just did the hot pass. There would be another fill and a split pass cap. By implementing the Mini Pantheon, what we found in some of our time studies is that you will see a 30% productivity gain just by removing the operator, or removing the torch from the operator's hand and implementing the Mini Pantheon.
That's great. All right, as I understand it, I'm hearing we have some questions.
We do, Sheldon. All right. So the first question is centered around power requirements for the PipeFab.
Okay, so the PipeFab has what's called Power Connect technology. That's a Lincoln Electric patented technology that allows it to take in any three-phase power from 200 volts to 600 volts. So what's nice about that is in certain areas of the country or the world may have 460, that's not truly 460, it might be 475, it might go all the way down to 420, and it'll be able to compensate for that and maintain a great stable output of the machine regardless of the power that goes in.
Great. Our next question is around language set. Is this available in different languages?
It is. So the PipeFab is actually available in multiple languages. We have 12 actually translated today, and there are more coming with future updates.
Our next question is, why did we choose the consumable that we have on there to do the demo currently over another consumable?
So RedMax really capitalizes the short arc welding characteristics that we're really looking for this demo. So RedMax is the short arc, the wider base of the arc, and basically helps wet in those toes that much nicer.
Great, thanks. Are there kits or packages available for the system setup we see today?
So the PipeFab is available in a Ready Pack, which comes as you see it there, minus the cooler. What's nice about the Ready Pack is you roll it off of the pallet exactly how it sits. So it comes with the wheels on it, it has the feeder already mounted on top, you just add your wire. Now, the Pantheon is also available in a Ready Pack that comes as you see here, and you can give it the 250-pound positioner. The last Ready Pack will be the trifecta. You get everything you see here all together. The positioner, the mini Pantheon, and the PipeFab all in one.
Okay. Our next question is centered around recommended gas for the system setup we have today. Can you talk to that about the gas recommendations?
Yeah, so of course we use a 98.2, so argon and then CO2. Oftentimes you can use an O2 as well with the 2%. Ladder. Trimix is also really for the optimum results, but ultimately helium is really at a shortage. I think a lot of people are seeing that now, so this is the most readily available and most cost effective.
And I think this will probably wind up being our last question for the day. Is there an option to control the PipeFab system remotely?
Yes, so if you guys saw, I'm making the settings here, Eric is welding here, and in reality that's not always practical, right? So instead of having to do that, we have something coming out very soon. So it's not out today, but it will be launched shortly, and it is a PipeFab remote UI. So this has all of the same controls that are on the PipeFab feeder, but remotely, and you can just place it right here and control it from there.
It's important to note, Sheldon, that also one of the things as an operator we would like to see is where we have adjustment. If we wanted to cold inch the wire out, if I needed to feed a little wire out to line it up to my joint, I have the ability to do that right here.
Absolutely.
And I also would be able to do gas purge. And once you implement this, you still have the abilities to have the multi-process machine, which is what the PipeFab is, where I can switch between TIG, MIG, stick, flux core, even with a remote pen.
Absolutely.
Well, I'd like to thank everyone for joining us today, especially our product managers and Eric. We'd like to invite you to join us again at a later time for a different demonstration. If you have questions or would like more information about today's demonstration, go to lincolnelectric.com/pipe. Thank you all for joining. See you again.